As a part of mean value theorems in the last class, we learnt about the statement of Rolle's theorem and some simple problems related to the Rolle's theorem. And this is the problem which I gave you in the last class, and now I am going to discuss it in this class. See, this is the function f of x, and the definition of the function is this: x power alpha log x base e for x greater than 0, whereas its definition is 0 if x not equals to 0, right? If x is non-zero value, then f of x, see one thing, see this is x is equals to 0, I think so. If x is equals to 0, f of x value is 0. If x greater than 0, f of x is x power alpha into log x base e, and for negative values it is not defined. Why? Because since log x is involved, if x is negative, logarithm is not defined. So if x is less than 0, this function not exist. Okay. Rolle's theorem is applicable to f in the region x belongs to 0, 1. As per the statement, Rolle's theorem is applicable. See, if Rolle's theorem is applicable, what will happen? If Rolle's theorem is applicable, then f is continuous in that region. Since Rolle's theorem is applicable, f is differentiable in this region. Since Rolle's theorem is applicable, f of 0 is equals to f of 1 will happen. Since Rolle's theorem is applicable, these three statements are true for the given function. If these three statements are true for given f of x, from there we need to get the value of alpha. That's our task here. See, f of 0 is equals to f of 1. Is it clear or not? F of x is equals to 0 if x is equals to 0. That means f of 0 value is 0. F of 1. If you replace x with 1, logarithm of 1 is 0. So f of 0 is 0 directly, and this is 1 power alpha into log 1 to the base e. So 0 is equals to 0. This is always correct. Since this is always correct, this condition won't help us to get the value of alpha. Next thing is f is differentiable. See, f of x is this particular function, x power alpha into log x base e, and we are just thinking in the positive region only because x belongs to 0, 1 as I said. You just try to calculate f dash of x. If you write f dash of x, and this is, you need to use product rule. First function x power alpha into the derivative of second one, which is 1 by x, whereas the second function log x to the base e into the derivative of the first one, which is alpha into x power alpha minus 1. If you observe this, see, the question is saying that Rolle's theorem is applicable, that means f is differentiable. Since f is differentiable, whether it is right or wrong, we are checking now. See, just look here, this is equals to what? X power alpha by x, if you pick out, you left with 1 plus alpha into log x to the base e. In this particular region, x belongs to 0 to 1. Okay. See, in this particular region, this is always differentiable, except this first point 0, and clearly we have here x greater than 0 because we differentiated this function, right? X greater than 0. That means denominator is never 0. Since denominator is not 0 and the numerator exists for all x greater than 0, so f of x is always differentiable in this region. So f of x is always differentiable in this region. F of 0 is equals to f of 1 always happens in this region for the given function. So this second statement also not useful for us to find the value of alpha because it is always correct. Then the first condition, f is continuous. Since f is continuous, see, at x belongs to 0, 1 and the function is different at 0 and at x greater than 0. Since it is continuous, we know that limit x tends to 0 plus f of x is equals to f of 0 as per the definition of continuity. Limit x tends to 0 plus f of x is equals to f of 0. Now I will use this first statement to get the value of alpha. So this implies I am just trying to get the value of alpha. Limit x tends to 0 plus f of x, that in the sense for x greater than 0, x tends to 0 plus in the sense x is more than 0, so use this one. So limit x tends to 0, x power alpha into log x to the base e is equals to f of 0 is 0. This limit value is 0. From there we need to get the value of alpha. We need to fix the value of alpha. Limit x tends to 0, x power alpha into log x base e. How to solve this? As x tends to 0, log x. Okay. And this implies limit x tends to 0 and particularly 0 plus actually. Okay. Limit x tends to 0 plus, since we don't know alpha. Limit x tends to 0 plus log x base e value is how much? Is minus infinity actually. From the graph it is very clear that as x is tending to 0 plus, log x to the base e value is minus infinity. Since this value is minus infinity, but we need to get 0 as our answer, so we need to rearrange it. That's why I will rewrite it like this: log x to the base e divided by x power minus alpha, and that is equals to 0. If you apply as x is tending to 0 here, as x is tending to 0 and 0 plus, this log x to the base e value is minus infinity, and as x is tending to 0, x power minus alpha is 1 by x power alpha, so its value is again infinity. It is of the form infinity by infinity, but I need to get 0 right. Since it is of the form infinity by infinity, we need to use L'Hospital rules there. So that implies
Hello, sir.
see, to get 0 and this side actually infinity by infinity. This infinity by infinity, if you have for limits, we will go with the L'Hospital rule. So use the L'Hospital rule. That implies limit x tends to 0, derivative of log x base e is minus x, and its derivative is minus alpha into x power minus alpha minus 1, and that is equals to 0. Right? If you try to solve this, x and then minus alpha. So that implies limit x tends to 0 minus 1 by alpha into x power, see, x minus 1 plus 1 gets cancelled, we will get x power alpha, that is equals to 0. See, limit x tends to 0 minus 1 by alpha into x power alpha is 0. If you replace x with 0, directly we will get 0. But it is possible only if alpha is positive. Just have it. Limit x tends to 0 minus 1 by alpha into x power alpha is equals to 0 is the step at the end we have. This is correct. If you replace x with 0, clearly the limit value is 0. That statement is correct. But that statement is correct only if alpha greater than 0. If this power alpha negative, then again you will get this left side value as infinity. But since we have to make it equal to 0, because the question is accepting Rolle's theorem, so f is continuous. Since we have continuity, the left side value for sure it is 0. It happens only if alpha greater than 0. So at the end we have one restriction on alpha. That's it. Okay. For the given problem, finally we conclude that alpha greater than 0, alpha is positive. So we need to take any positive value in the place of alpha. If you take any positive value in the place of alpha, always Rolle's theorem is acceptable. But for the given options, only this 1 by 2 is the positive value, and your answer is option D for this problem. Usually you will face these type of problems for objective examinations based on Rolle's theorem, right? As per the given statement, the function accepts Rolle's theorem. The Rolle's theorem is applicable for the function. That in the sense, these three conditions are correct for this function: continuity, differentiability, and the f of 0 is equals to f of 1. F of 0 is equals to f of 1 is always correct. So this statement is not useful to decide alpha. F is also always differentiable. So the second statement is also not useful to decide alpha. Whereas since f is continuous, right limit is equals to f of 0. From there we conclude that alpha has a positive quantity, and from the options your answer is 1 by 2. There ends the problem. Okay, just have a look.